What's the next word? It's bicarb soda. So, this people often call this bicarb soda. It's actually sodium bicarbonate. Okay? Technically, sodium hydrogen carbonate, right? But sodium bicarbonate, yeah? It's baking soda, right? We have this in the kitchen at home, yeah?
Yeah.
So, we have that. And
Rocket ship.
what's this? Read the green writing on the white background. What's that there say?
Wait,
The V. No, with the V.
here?
Yeah.
Vinegar.
Vinegar. Yep. So we've got sodium bicarbonate and vinegar. Okay.
Yeah.
Now they're going to have.
The rocket.
Yeah, and the rocket. You're right.
And the launch.
Correct. But the rocket's just the thing around the fuel.
Yeah.
That's fine. Just be careful. The sodium bicarbonate, guys, and the vinegar. It's going to have a chemical reaction. Okay. And it's going to make carbon dioxide.
Yeah.
That's a gas. That's CO2 gas.
Yeah.
Okay. And the thing is,
That's gas.
gases take up more space
Yeah.
than the liquid and the solid.
Yeah.
So that's going to build up pressure in the little launch tube here, and when that pressure is enough, the rocket's going to go
Into the sky.
into the sky.
And through the
Let's have a look, hey? Okay, let's take a quick look at the chemical reaction which is about to occur. One of the ingredients, one of the reactants that we're using is baking soda. Now, baking soda is sodium bicarbonate. This is the equation. I also called it sodium hydrogen carbonate. That's because we're starting with the sodium ion and this other guy here. Now, this is the bicarbonate ion, hence the sodium bicarbonate, but technically it's the hydrogen carbonate ion because here's another ion, CO3 2-. This one is the carbonate ion, and what we've done is added a hydrogen. It's actually called the hydrogen carbonate ion. However, when we put that all together, we often just say this thing is the bicarbonate, and then we add the sodium, so we have sodium bicarbonate, or as I mentioned, often called baking soda. Oh, eraser, what are you doing? Erase. Goodness me, having issues with the stylus. Maybe I should have just left it. That's okay. We're nearly tidied, nearly clean. There we go. Wow, that took a long time. Anyway, so there's one reactant, our baking soda, the sodium hydrogen carbonate or sodium bicarbonate. We're reacting this with vinegar. Now, vinegar is actually acetic acid. So we write the formula for acetic acid as this. Now, we could have written C2 because we've got two of them. We have four, I said silly stylus, 4 hydrogens and 2 oxygens. This we could have written for the acetic acid, but it doesn't really tell us about the makeup of the molecule. All it tells us is that, well, somewhere we've got 2 carbons, 4 hydrogens, and 2 oxygens. So it's actually preferred to write it like this, because this tells us how the molecule is actually made up. Okay, this tells us that, well, let's see, we start with a carbon, we have 3 hydrogens bonded to that carbon, and then we've got another carbon. Now, off this carbon, we have a hydroxyl group, and we've got an oxygen. Now, that other oxygen has to be double bonded because of carbon forms 4 bonds. We've got hydrogens here, we often just don't show the hydrogens. So, by writing CH3COOH, that shows us the actual makeup of the molecule. Now, when you see COOH, that part, this part here, that should tell you straight away, yeah, that's an acid, because this is an alkanoic acid. All right, the C double bond O also bonded to OH. This is what makes it an acid. Okay, so vinegar is actually an acid because this hydrogen here will break off and go elsewhere. That's essentially what makes it an acid, the fact that it is able to donate that hydrogen ion. Okay, so acids are proton donors. Anyway, we might get into that a little bit later on. So, this is what we have. Wow, having real trouble with the eraser today, silly stars. Okay, so we've got baking soda and vinegar. In fact, let's write those in. This is baking soda. or sodium bicarbonate, or sodium hydrogen carbonate. This is vinegar, or acetic acid, or ethanoic acid. Actually, its proper name is ethanoic acid. Eth meaning 2 carbons. Okay, so if you've got 1 carbon, meth, 2 eth, 3 prop, 4 bute, and then after that, actually after 4, then it goes normal. Then it goes pent and hex and hept and oct and non and dec. So the normal prefixes that you'd think of, right? But the first 4, meth, eth, prop, and bute, are still used for historical reasons. So this is ethanoic acid, or ethanoic acid, because there are 2 carbons. Often just called acetic acid. What we're calling it, because this is kitchen chemistry, is vinegar. Now, these 2 things are going to react. All right, now I said actually that we're going to make some CO2 gas. Okay. Actually, what we could do is say that it's a gas. There we go. We should probably do that. The baking soda was a solid, so we can put in our states here. Now, the vinegar, you might think, oh yeah, that's liquid. Yep, sweet as. Actually, it's not. It's actually an aqueous solution. So we write AQ. Now, when you're writing your, oh, that looks funny. When you're writing your chemical equations and you're putting in the states, there are actually 4 options. You could have solid, liquid, gas, or aqueous. Now, aqueous is not another state of matter, even though we say, oh yeah, put your states in, show your states in your chemical reaction. It's not a different state of matter. It just means that that thing has been dissolved in water. All right, aqueous, it's in a watery solution. So those molecules have been dissolved in water. And in fact, actually, all acids, any acid you ever get, is mostly water molecules. Okay, but we'll talk about that later on as well. So we have solid sodium bicarbonate. We have an aqueous solution of ethanoic acid or vinegar. Where we're going to produce CO2 gas, we're also going to produce some water. Now this is just water, so this is legit a liquid. And we're going to produce one other product. Now, look at the reactants and see, oh, what else are we missing? Well, we're missing some sodium for a start. Okay, so we're going to make some sodium something or other. We're actually going to make some sodium acetate, or sodium methanoate. Okay, so we're going to have sodium hooked up to the CH3COO. Now, if you remember back what I said happens with this ethanoic acid, right, was that hydrogen bugs out. Well, when that bugs out and it has a positive charge, what's left behind is going to be negatively charged, which is therefore attracted to another positive charge. So these guys are going to hook up. When the acid does its good little acid thing and donates that hydrogen ion, then what's left over, the acetate ion or the ethanoate ion, will hook up with the sodium ion, and we get this sodium acetate or sodium ethanoate. Now, this is actually aqueous. It's an aqueous solution of that, which means we don't actually really have that in solution. What we actually have is sodium ions and the ethanoate ions, the acetate ions. Okay, so technically, we wouldn't actually have this. What we would have is a sodium ion, aqueous solution. We would also have the acetate or ethanoate ion, and that would also be in an aqueous solution. But, you know, technically, if we're starting like that, we wouldn't actually have this either. We would have the acetate ion, and we would have the hydrogen ions, right? So, you know, let's not worry about breaking that up. That is the product that is formed, but because it's actually an aqueous solution, it is actually separated into the 2 ions. Okay. Let's try and keep it tidy. If the eraser will keep working. Yeah, we got there. Right, so there's our reaction. Took a little bit of getting there, but we got there in the end. There's our chemical reaction that's about to happen. Okay, so starting with our baking soda and our vinegar, we combine them. We're going to make sodium acetate or sodium ethanoate. We're also going to get some water, lovely, and we're going to make some CO2. Now that's a gas, and of course gas takes up a greater volume than solids and liquids. Just depending on what the gas is. Like, as an example, H2O. Okay, if you took liquid H2O and you had 1 mil, so 1 little mil of water, and you converted that to gas, right? So you evaporated it, but very, very quickly. So let's say you flash boiled 1 mil of water. That would actually occupy 2 liters of volume. Okay, 2 liters of space. So that one tiny little mil, a thousandth of a liter, expands to fill 2 liters when it converts from a liquid to a gas. So gases really do take up more volume than solids and liquids. All right. This is because the particles have more energy, so they're moving around more, taking up more space. So we're making that gas, the CO2 gas. And it's going to want to take up more space, so that will build up pressure in the launch tube. And the pressure has to give. Either the launch tube is going to just smash apart, or wait, there was a hole at the top. I know, let's relieve the pressure out the top of the launch tube. Wait, there's a rocket in the way. Tell you what, let's push the rocket out of the way. Right, that's essentially what's going on. The pressure from the buildup of the CO2 pushes the rocket out of the way, so it pushes it up into the air so that the pressure can be released. Now, what we have in front of us is the overall equation. It's actually not quite that simple. It's actually a 2-step reaction. What I've written is the overall reaction. But first, what we're actually going to make is this stuff. What have we got? Hydrogen carbonate. Now, this is carbonic acid. This is what we're making. Okay, we're making sodium acetate. That's this down here. And we're making this hydrogen carbonate, which is carbonic acid. Now, this is actually quite unstable, and this undergoes another reaction, a second reaction, which breaks down into the carbon dioxide and the water. That's a decomposition reaction. So first we have a double displacement reaction going on. Okay, double displacement reaction. And then, so actually, what does a double displacement reaction mean? Let's quickly look at that. Double displacement means 2 things are going to change places. The hydrogen here and the hydrogen carbonate here, they are going to hook up. Okay, so this hydrogen on the acid is going to leave the acid and go to the bicarbonate, and that leaves the sodium to hook up with this acetate ion, the methanoate ion. Okay, so 2 switcheroos have actually taken place. Okay, so that's why it's called a double displacement. The hydrogen displaces the sodium, or the sodium displaces the hydrogen. It goes both ways. So it's a double displacement reaction, aka a metathesis reaction. So that's what we have going on first, and that's what makes our H2CO3, our carbonic acid, which is unstable, and so that then dissociates, breaks apart into the carbonic acid, not the carbonic acid, the CO2 and the water. Okay, so it's actually a 2-step reaction, but if we go from our start to our final, then this is what we have. Because that carbonic acid, the H2CO3, it really is not going to hang about. It's not going to stick around. Oh, I'm having issues with the eraser. Goodness me. So, like I say, this is the overall reaction, where really it's 2 reactions, but this is what's going to be going on. I have been talking too long. Let's get on with the rocket. Right, Ken, you got the rocket?
Yep.
Excellent. What we've put in here is the liquid part of the fuel.
Yeah.
Yeah, the vinegar, didn't we?
Yeah.
And here's the solid part of the fuel, yes?
Yeah.
We've
and
got
then put that on it.
That's correct, we are. We've got a liquid-solid fuel combination, don't we?
And we have to run away from it so it doesn't land on us and hit our head.
Well, we are going to stand back, so that just in case it's a bit windy, if the wind blows the rocket over just before it launches, we don't want it to launch at us, do we?
No.
No, that's why we're going to stand back, okay?
Yeah.
Okay, Alice, hold.
And also it's a little bit windy, so
it is a bit
maybe
windy.
It might not. Ken, stand back. Yeah. Okay.
Okay, we're good.
Yeah.
We're just gonna, I have to put this in here, and then we're gonna mix them up a bit, okay?
Yeah. Okay.
Hang on.
Wait, with what?
My hand. Well. Well.
That did not
That went
work.
up quickly. It said mix it twice. Give it 2 shakes. You know what we need to do, Ken? Let's start again.
It's recording. Yeah.
Okay. Trial 1. It went pretty quickly.
Yeah.
Didn't it, guys?
Yeah. So.
Instructions did say shake it twice.
Yeah.
Yeah? Did we have time to shake it, Ken?
No.
There was no time, was there?
No. We didn't even shake it once.
I know, right?
Yeah.
That's okay. Because, hey, what if something doesn't work? What do you do?
Try again.
Try again, that's right. That is exactly right. And that's what we're doing, hey?
Yeah.
So we'll try it again. You go the lid? Yeah, cool. Put the lid on. Good job. Thanks. Alright.
Stand back, Kian. I'm in the hole.
Why? Because you saw what happened last time.
Yeah.
Alright, are we ready, guys?
Yeah.
Are we set?
Yes.
Am I going to shake it or am I just going to put it down?
Shake it.
Shake it? I tried shaking it last time. That didn't have time.
Shake it.
You can stop.
Look at that.
Yeah, you can stop recording now.
It's going.
Ken, what happened?
Got on my hand a little bit.
The vinegar?
Yeah.
Yeah, but that's okay because it's just acid, hey?
Yeah.
Yeah, did you know it's acid?
No.
No, but it is. You got acid on your hand. What? Quick, wipe it on the grass. That's not the grass, it's your hand. No, you're fine. Hey, it is actually acid. Vinegar is actually acid, okay? Vinegar, guys,
Yeah?
is acetic acid, okay?
Okay.
Its actual name is ethanoic acid. It's a very weak acid, okay? Also, it's very dilute. So it's a dilute, weak acid, so it's not bad, hey?
No.
Not bad if we get it on. All right. Okay, let's just break that down a little bit. A dilute weak acid. What the heck is going on? First, the definition of an acid. An acid, here's an acid as an example. Here's another acid, the example that we're actually using. So the first one is hydrochloric acid. The second one is acetic acid. Hydrochloric acid you will find in your tummy. Okay, hydrochloric acid is the acid that you've got in your stomach. You know about this if you ever vomit and it hurts your throat because it's what was acid that came up through your throat, so that damages your body tissue, and that's why it hurts when you vomit, because you've got acid in your stomach. And the other stuff is vinegar. All right, commonly called vinegar. What it actually is acetic acid or ethanoic acid. Ethanoic acid. Well, C didn't work. There we go. So there we go, hydrochloric acid and acetic acid. Now, why are these actually acids? Well, the definition of an acid is a proton donor in an aqueous solution. Okay, so in an aqueous solution, oh, what just happened? You go away. There we go. In an aqueous solution, these things are proton donors. What that means is that these hydrogens actually bug out as the hydrogen ion. Okay, so this, oh goodness, issues with stylus. Okay, so the hydrogen on the end of the acids there, that leaves. Now, actually, this is why we write vinegar as the Chikoo, CH3COOH. Anytime you see COOH, you think, oh, acid, because that shows us that it's actually this hydrogen that is leaving, that is being donated. It's not one of these 3 hydrogens. They're just nicely attached to that carbon. They're nice and stable. It's the other hydrogen that bugs out. Now, hydrogen ion, the H+. Well, what exactly is that? Hydrogen is 1 proton with one electron orbiting around it, right? That's the hydrogen atom. Now, the plus says that an electron is gone. So we don't have an electron orbiting our proton. So the hydrogen ion is essentially just a proton. So that's what acids are. They are proton donors, meaning they will donate a hydrogen ion, which you could just call a proton. Okay, so an acid is a proton donor in an aqueous solution because this stuff, HCl, this is not an acid. This is actually a gas. Okay, it's called hydrogen chloride. Only when you take that gas and you dissolve it in water to make this aqueous solution, then you have an acid and you can call it hydrochloric acid. Okay, so HCl, that's a gas, hydrogen chloride, dissolve it in water, which is what this AQ means. Okay, that's a watery solution. It's been dissolved in water. And now it's an acid, and it's hydrochloric acid. So that's the first thing. That's what an acid is. It's a proton donor in a watery solution. Now, another thing, strong versus weak. Vinegar is a weak acid. Hydrochloric acid is a strong acid. Okay, anytime anyone says strong acid, you should immediately think hydrochloric acid, H2SO4, sulfuric acid, and HNO3, nitric acid. Okay, there are other strong acids, but these are the three that you use in school. We tend to use hydrochloric acid, sulfuric acid, and nitric acid. We use those all the time. So a strong acid means that the acid molecule essentially completely dissociates or completely breaks apart. So all of these HCl molecules are going to do this, bug off with an H plus, and that will also then leave a Cl minus, right? So pretty much all of those molecules are going to break apart. They will dissociate. That's what a strong acid does. It completely dissociates. We say completely, that's a bit of a simplification. It's not quite all of the molecules, but most of them. And now, a weak acid, well, that's the opposite. Very, very few of the acid molecules actually break apart. So we said, hey, this is going to be a good little acid and donate that hydrogen ion. It's going to be a proton donor. Yeah, but some of them will do that. Some of the molecules will actually stay intact and they actually won't dissociate. Okay, so a strong acid completely dissociates, and a weak acid only, we say, partially dissociates. So some of these molecules will donate that proton, and the others actually won't. They'll just stay as CH3COOH. Okay, so an acid is a proton donor in an aqueous solution. A strong acid completely dissociates or completely breaks apart, and a weak acid only partially dissociates or partially breaks apart. And by partially, we really mean sweet stuff all. Very, very few of them. Now, the other thing was concentrated and dilute. Well, here are two solutions. Let's throw in something that's going to dissolve. Let's throw in lots into... I don't know what's going on with my stylus today, but anywho, lots and lots of particles. Okay, let's dissolve all those, and in the other solution, we'll say put 5 particles. So on the left, we have a concentrated solution, and on the right, we have a dilute solution. It's diluted. So what the heck does this mean, concentrated and dilute? Well, a concentrated solution is one in which there are many solute particles. So lots of the particles that have been dissolved, there are heaps of them there. And as you can see, I drew lots. In fact, I'll even add a few more. So this is a concentrated solution because there are lots and lots of those solute particles, the parts that got dissolved. Now, in the dilute solution on the right, we have very few particles dissolved, right? In fact, we've only got 5. So this is a dilute solution. Okay, so vinegar is a weak acid. It will only partially dissociate. It will partially break apart. And also, like acetic acid, you could get concentrated acetic acid. It will be concentrated of a weak acid, but what is sold in the supermarket as vinegar, that's not concentrated. That is dilute. Okay, so if you're going to be playing around with an acid, the best one to be playing around with is a dilute solution of a weak acid. All right, a weak acid already not so bad, because it will only partially dissociate, partially do its little acid thing and donate the proton. And also it's very dilute. It's mostly just water. There are hardly any of the acid molecules there in the first place. Right? And then only some of those will do the acid thing. So if you had to play with an acid, you would choose the dilute weak acid. That is the safe version. Right? You don't really want to be playing around with a concentrated version of a strong acid until you're in college doing senior chemistry. Then it can be quite fun. But anywho, so there we go. That's what we mean by vinegar being a dilute weak acid. Now, back to the launches. Let's give this a go, yeah?
10.
T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. I'm just going to go really quick this time, okay?
Yeah.
Yes, it's building up. That was a better launch. I'm not going to shake it at all. I'm just going to hold. There it goes. Cool.
Don't forget to hit the like button. Yeah. And subscribe to It's Up Here. And here's another video.